Prostaglandins are an important class of lipids. They are 20 carbon molecules with a 5-membered ring and 2 side chains coming off of 2 of the adjacent positions on the ring. So the prostaglandins are named with a letter, P, G, A, B, C, D, E, F, or G, depending on their substitution pattern. Okay, so as you can see, A, B, and C are all alpha beta unsaturated. Well, okay, A and B are alpha beta unsaturated ketones. C is actually a beta gamma unsaturated ketone. D and E are beta hydroxy ketones. And then F is a diol, and G is something that has 2 oxygens bound to each other, and that's actually called a peroxide. And in this case, it's called an endoperoxide because it's under the ring. Okay, so further parts of the name indicate the number of double bonds that you have in the side chain, and if it's a prostaglandin F, you actually have to consider the relative stereochemistry of the alcohols, of the 2 alcohol functional groups. And if the 2 alcohols are both pointing backwards and cis to each other, we consider that alpha. And then if the 1,3-diol, if the OHs are trans to each other, we consider that beta. Again, because if you look at the OH that's indicated in red in the drawing, if it's back, it's alpha, and if it's up towards you, it's beta. And then furthermore, in these names, PGF2 alpha and PGF2 beta, the 2 indicates the number of double bonds that you have in the side chain. So there's a total of 2 double bonds. Okay, so prostaglandins are actually important molecules biologically. They are biochemical regulators that are actually more powerful than steroids are. The name prostaglandin may sound like prostate gland to you, and there's a reason for that. When these molecules were first discovered, it was thought that they were actually secretions of the prostate gland, and they were actually first isolated from secretions from a prostate gland, but it is now known that they are secreted all over the body and serve a myriad of biological purposes. And since they are secreted all over, unlike steroids, which are secreted by one particular gland and travel around the body where they need to go, prostaglandins only function locally where they are synthesized. So some of their functions are to regulate blood pressure, blood clotting, gastric secretions, inflammation, kidney function, and of course the reproductive systems, taking us back to our prostate gland. So prostaglandins are important for many reasons. We can't just stop making them, but yet they have the bad rap that they are involved in the inflammatory response. And for many people who are in pain, they want to do something to reduce that inflammatory response. And that is a result of excess prostaglandins. Okay, so one emphasis of medicinal chemistry has been trying to reduce inflammation-related prostaglandin synthesis without, reducing the beneficial types of prostaglandin synthesis. And I'll have a little more to say on that in a couple of slides. Okay, so how are prostaglandins biosynthesized? So again, there's a lot of chemistry here that I don't really expect you to have mastered, but what is true is that they are made from arachidonic acid, which is the 20-carbon polyunsaturated fatty acid that has 4 double bonds. And the way you make the 5-membered ring is through an enzyme called cyclooxygenase, which is sometimes shortened to COX. So cyclooxygenase, as the name implies, causes cyclization, so you form the ring, but also adds oxygen. And as you can see, to get to a prostaglandin, to get to the amount of oxygenation you need in it, you actually have to add 2 molecules of molecular oxygen per arachidonic acid. So I'm not going to ask you to look in any more detail at the mechanism of this because it involves radicals, and we haven't really studied radicals yet. But you should still be aware that oxygen can get broken apart as necessary and can be put into the proper places using this enzyme. So, as I have said, one of the reasons we want to reduce prostaglandin synthesis is to reduce inflammation. And you have probably all heard of the class of drugs called NSAIDs, which stand for non-steroidal anti-inflammatory drugs. We looked a little bit in the previous lesson at how prednisone functions as a steroid anti-inflammatory drugs. But the non-steroidal anti-inflammatory drugs are actually inhibitors of this enzyme called cyclooxygenase. And the most well-known NSAIDs are aspirin, or acetylsalicylic acid, naproxen, or ibuprofen. However, anybody who's taken any of these drugs on a regular basis for pain knows that they have gastric side effects. Okay, so they cause stomach irritation. And if you think back to what I said on the last slide, prostaglandins are also involved in regulating gastric secretions. So we actually later discovered that there are two cyclooxygenase enzymes. So COX-1 synthesizes the prostaglandins that are responsible for protecting the stomach, while COX-2 synthesizes the inflammatory prostaglandins. So that led for a search for molecules that would selectively inhibit COX-2 and not inhibit COX-1. And 3 such molecules became drugs that came to the market in the 1990s, going by the trade names of Vioxx, Celebrex, and Bextra. But 2 of them were actually taken off the market 10 years later. Vioxx and Bextra were taken off the market. Celebrex is actually still on the market, but it has, a black box warning on it. It is the least toxic of the 3 of these, but still falling into the same class, and having a structural similarity to the other 2 can cause the same problem. And of course, the problem that is caused by these drugs are coronary side effects. But what I like you to look at this point is just look at the structures of Vioxx, Celebrex, and Bextra. And they were all developed by different pharmaceutical companies trying to get their foot in the door of this very important area. And their structures are as similar as they can be without infringing on each other's patents. So what that usually means is that they have changed the functionality at the central 5-membered ring heterocycles. Okay, so these COX-2 inhibitors prevent the synthesis of inflammatory prostaglandins by selectively inhibiting the enzyme responsible for their biosynthesis. Okay, so again, I'm just going into a little bit of the chemistry involved with prostaglandins. There's a whole lot more biologically to talk about, but since we want to move fairly quickly through this unit, I'm going to leave it at that and move forward in the final lesson in this unit to talk about lipid vitamins.